When analyzing time series, it can be useful to see how multiple variables change over the same period. This can lead to the discovery of correlation between pairs of statistics and relate patterns in the data to real-world events. If one wanted to answer the question, how quickly did California vaccinate its population in comparison to New York, and how did that affect case numbers? They would want to see graphs side by side, one showing vaccination numbers and one showing case numbers. The timeline panel from ITLab features 3 datasets: World, listing by country; India, listing by Indian state; and USA, listing by US state. This data provides a basis for a demonstration of the two-graph visualization technique. The timeline panel is one of several sites within the CoWiz domain, and so it inherits much of its architecture from the broader project. The site is served by the Flask web server for Python, running behind Nginx on a Linux server. Data files are updated from our sources using scheduled scripts and are read by Python using standard file I/O. On the front end, some page styling is handled by Bootstrap CSS, and the timeline component itself was written specifically for this application in jQuery. The JavaScript is sent to the client along with the requested time series data, where the interactive graphs are rendered. The visualization module consists of 4 main elements: 2 graph classes, a bar class, and a dash class. Each graph contains an HTML canvas element, commonly used across the internet to draw graphics. The graph class also handles the logic of plotting data with the appropriate position and scaling. The bar class draws the scroll bar along the bottom and is triggered by mouse events, relaying data to other elements in the dash about user input. The dash class stores all the data sets as well as references to the 2 graphs and bar, allowing each component to communicate with the others. Here, I'm viewing the CoWiz++ homepage. Along the top are 2 information boxes, the top displaying current case and death tolls queried from the World Health Organization database. The other box is a scrollable list of links to recent New York Times articles related to the coronavirus. The map on the right side is a link to the Chloropleth map visualization panel, an earlier ITLab project. On the left side, the timeline can be accessed via buttons that correspond to the datasets we currently have available. For this demonstration, I'll choose World. In the first drop-down menu, the user may select up to 5 regions. The next 2 drop-down menus are used to select the features that will be compared. After the graphs are generated, a legend is displayed that indicates how line colors correspond to each region. Individual lines can be toggled by clicking on a legend item. In the title of each graph, the vertical range of the data is printed. Each graph has its own vertical scale, but the horizontal scales are the same. While hovering over a graph, a crosshair indicates the mouse position on both graphs. When near a plotted data point, a tooltip is drawn which shows the exact value at that point. The bar below the graphs scrolls them in unison with the user clicking and dragging. In previous iterations of the timeline panel, the Plotly library for Python was used to generate line graphs with built-in features like zoom, animation, and information boxes that follow the cursor. However, pages took up to 5 minutes to load using this package. With a custom JavaScript module, the performance has been greatly improved, loading the graphs in an order of magnitude faster. When the user submits a form, its parameters are sent to the Python backend to read the appropriate data file, and the columns of interest are sent back to the client for rendering. As a direct result of this approach, the site works for any correctly formatted CSV file, improving modularity over previous iterations. Another consequence of this approach is that the data is displayed exactly as it's found in the CSV files, so if data is missing, that is also shown to the user. Some processing could be done on the back end to handle incomplete data, like computing a 7-day rolling average instead of plotting each point individually. The JavaScript module on the timeline panel was designed to trust its data sources and be a lightweight replacement for Plotly, eliminating the need for loading screens and a complex caching system. For more information, please visit our website at itlab.uta.edu.